Hey there, myself Krish Raithuk and very warm welcome to all, and very warm welcome to the System Design Fundamental. And today we discuss a little bit about the concept of the low-level design, where we actually focus on their concurrency and multi-threading. And today we actually focus on that basics of the concurrency and multi-threading. This is important to know because of that what the we are trying to do here. Like this particular concept is all about something. We are discussing, as you know, like software and operating system both are individual part, like both have an on uh, have different like different scenarios on what they work, and they both have different mechanisms too. So software is all about like run on that operating system. So we discussed concurrency and multi-threading help us to know about like how actually software and the operating system communicate each other, to what the process that you should to know before building any software. Like concurrency play important role and multi-threading play also important to do, just link that gap between, just fill the gap between both of them, like operating system and software. So when you just Mac application, you should to know like how actually this your particular system communicate with the operating system. That's a very important one. So overall agenda for today, what we're going to do here, like the first stage is like little bit about, we discuss processes versus thread. This is a basic fundamental, and I will try to connect all the real world application and technical terms with the real world application to explain you that particular concept, to more about it concepts. So initially the I put my best effort on that particular one, like process versus thread, to explain you much better about it, like by connecting with real world application and all about it. Second is like we discussed a little bit about how to apply. So I just uh, make bit of changes in that my presentation style. Little bit about what I make to change here. Like first we discuss concept. Second we discuss how can we apply that particular concept. So second part is very important because of that. Uh, it's not all about like what you're thinking about it. So it's all about like how can you apply it. So that's a very important. So applying that concept is really matter when you're discussing that particular. So discussing idea is not alone that you know much about that particular system, is important to just how can you apply that your idea to the system to understand your to solve the problem. So that's the basic thing. So our last agenda is all about based on like how can you apply that particular concept, and I give my best effort, like 100% effort to just I put my 100% effort to explain that particular one, to how can you apply that particular concept. So again, if this one going to productive for you, if you learn something from there, then it's my pleasure. So let's start. Hey, let's come to agenda number one. And in this agenda, we actually talk here like a little bit about processes and thread. So let's start. So when we're talking about processes and thread, this is a very important concept of when you actually understand their concurrency and multi-threading. So processes is like something, yeah, it's all about like something application. You when you actually run your application on your particular operating system. So when you actually try to make application, so you need to just make a particular pathway or bridge between operating system. Let's suppose your application needs some specific memory to work on that. So how can you just talk to that particular operating system, how your particular application talk to your operating system to uh, manage that particular memory. So that's the basic process is like something, okay, it's all about like a particular independent executed process, executed software. Let's suppose it is software. Let's suppose software which actually want to run with an individual, like without a separate memory. It's called that particular one is called processes. Like something, okay, that's something execution happen in separate memory. Okay, so that's the basic processes. And when we're talking about multi-threading, so it like inside the processes, a small unit of the memory is shared. That's the basic for execution of the task. It's called a thread. So that's the basic. I give you a technical definition of the all about it, that both of them like process and thread. But the main important part, I would try to connect with the real world analogy also to understand you, explain you much better about it. So let me take two example for the best example, like restaurant example, and I think like it's very helpful for you for understand much better about it. Let's suppose McDonald's and the KFC. There's a two restaurant here, and I picked this for both of them because of that. I know this is too much famous right now, and people know and relate more about it. Okay, so let's suppose process one considered in they both work on same area, okay, same area. Okay, let's suppose same city, but they have a different restaurant and they different style, and they have different working model, internal working model, external working model, all the particular stuff. So they both have a separate same city, but they're different processes. So we can consider this both as a different process. Like process one is like McDonald's. This is also restaurant. Process two is KFC. This is also a processes. So they both have different a in the same city. They live. They have different status of work. They need separate area to work. Not that they are not combined with each other. They are not interdependent from each other. So similarly, like okay, that's the basic thing in the processes. And when we're talking inside the processes, let's suppose we're talking about like food delivery system. The both all the particular restaurant nowadays are linked with their some specific food delivery partners like Zomato or something like Swiggy and all the particular stuff. So inside the working model, like separate kitchen, manager, resource, and no direct sharing. So separate kitchen, they all the both restaurant have own separate kitchen, and a manager who actually manage all the tasks, and resources, they have own resources like ingredients and all the stuff, all the particular packaging food items, something, all the particular stuff. Okay, so that's the basic. They have internal structure here. So in that part, the internal part, they have all the particular stuff, and that particular stuff is called you can say uh, this particular stuff is called thread. Inside it, uh, they both have on threads to work. If I give a technical definition from each other, like okay, McDonald and KFC is a two different chapter. Like this is a process, so they'll consider this one different process. So if I replace this particular stuff with their technical terms, let's suppose we replace McDonald's with the VS Code, and this is YouTube. If the both application want to run in that particular software in particular computer or particular system, then I think like they both need a separate memory for to work. They're not interdependent from each other. Okay, okay, so that VS Code and YouTube, so processes and thread help us to communicate to particular machine, to operating system, for just okay, yeah, let's suppose the processes and thread are talking to operating system. Hey, I need some kinds of the memory, some memory space for running my application. So operating system say, yeah, you can take it, that particular this particular space is left here right now, and you can run that particular one, your application. So similarly, like okay, McDonald's and restaurant have its own internal working model. It's not about our domain to discuss like how it. So inside it, the system have all the particular units are shared. Is called the thread. Thread is like internal working structure. Like similarly, in restaurant have the separate kitchen manager resources. So McDonald's have that particular one. So all the particular stuff inside it, the running behind the scene. Let's suppose they are connected with a food delivery partner like Zomato, and someone can order it. They have a separate kitchen. The staff come here and just use that resources and manage the resources, and they share the kitchen to work efficiently. Lots of stuff. If I move toward their more about like food delivery partners, let's suppose if we zoom to their process one, process two, KFC. Like first is the cooking staff, which is thread one, order staff, thread two, packaging staff, thread three, delivery coordinator, which is thread four. Uh, there is all the threads inside their particular McDonald. Okay, they work each other. That work efficiently. Their cook staff, order staff, all they come together and just share the kitchen and just do all the particular task. So inside inside the processes, the anything work inside the by using a sharing memory, they execute a task is called the thread. So thread is a small unit inside the small shared unit inside the processes, which is actually responsible for working all the particular executing a task. So that the basic thread is. So that's the processes, process one, process two, and that's I try to connect with the real world analogy for understand you much better. Okay, again, if I talk about the one issue here is like little bit about one potential issue. I think in that particular software is right. Anyone can any particular system faced because of that. This particular issue is really solved. I will try to explain you how you can solve. Let's suppose all the threads are here, like cooking staff, order staff, packaging staff. If if you okay, so the one way is like when actually application run, they use some memory spaces, read and write. Okay, that's particular. Okay, fine. If the two staff come together and they are racing for same using resource at the same instant of time, what will happen? In that part, the synchronization come in the role to solve that particular problem. Let's suppose this is a particular resource. Okay, this is particular resource, and this is memory. And I think like two competitors, thread 1 and thread 2, are just try to just read and write information on that particular memory to use that particular memory, competing to each other, racing to each other. That is a potential issue for the processes. Thread 1 and here thread 2, they both are competing for the using that resources. I think synchronization here play important role. Because of that, synchronization helps us to lock that, use to the mutex locks to uh, just lock this particular resources for only for one thread. If that until that particular task will completed, then thread to come and just do that particular one they want to do. Let's suppose it's look like something like you have on a one whiteboard, but you are having a five peoples to just want to write at same instant of time. Then I think like only thing possible you can do here, like okay, you lock this particular whiteboard, everyone come to a step by step and individually one by one and just write in the particular board as is according to it. So sequentially work follow, sequentially process of work. So that's the basic thing that we are talking here, like synchronization. So this is a potential issue right now in that failure of operating system, but we try to understand how can we solve this by mutex lock. Mutex locks actually help us to solve that problem. It's lock the resources for only one thread at a time and until that completed the work. So that's all about it, that we are talking about thread, process and thread. In short, if you want to understand this process and thread, you're like, okay, process is like something application. You want to just run the application in that particular system or particular operating system. You need an isolated memory space to work on that. And that's the basic thing inside it. And when we're talking about like thread is like internal working model, like processes have some memory, and each memory needs some work. So processes, if I give example for processes like something YouTube and application, VS Code, like this kinds of the application. And when we're talking about threads, it is all about like something UI inside the particular app, like little bit of downloading features inside the app. So individual features which actually need to just some kinds of the computing power. So that is the thread. So that's all about for today's like processes and thread. And let's move to the second agenda to understand about how can we apply that particular concept to solve our problem in that real world problems. Let's come to agenda number two, and it is to actually talk about like how can you apply that concept, and that really necessary. And I put my 100% effort to just understand this particular one that you can say. So let's start with it. And I think the best way to understand like pseudocode, I will explain you like how can you apply that pseudocode. So let's suppose we are talking here and just we're trying to solve the problem in that particular pseudocode is all about like food delivery platform, where we talk about okay, a particular app if we is okay, so any app is run on processes like isolated memory space. So here just we start the algorithm and we need to decide the thread, what kind of how many threads are in that our particular software. So the first is like user interface, second is order preparation and the live tracking. So this is the few threads I want to just implement in my software. So I already decided this particular thread is okay. As we know, uh, for better management style, just we can focus on like each threads, how much the each thread occupy memory spaces. Yeah, according to it, that I think the process weightage of the process will increases. Process weightage of the memory will increase according to it. So thread 1 user interface, thread 2 order preparation, and thread 3 tracking, each occupy small unit of memory. Each of them occupy a small unit of memory inside the processes. So this is a entire structure of the application, and we decide in that code we actually decide. So actually that's important. So I decide the thread first, but at the first we need to discuss little bit about library. In Java have a specific library which is specially designed for communication for thread and processes in that little bit to deciding the threads to operating system communication. So you can use that particular library. This is inbuilt library here, and it's not only framework. So framework is not spatially is available for the processing thread. Like library of the any specific language, you can Python have also a specific library for this particular thread management and process management. So that's all about it. So this all about thread. And second, we need to just order preparation need with lock the kitchen. So we can understand we need to decide few logic of them, like we use mutex locks to protect their for synchronization process, we know. Second is like, okay, send payment and payment receipt order confirm. So that's the basic thing that we can say here. Like all the process of the software work like this, but here that what I want to explain you, when you actually write a code, you need to just implement that particular library, a specific library that uh, for better communication of their thread. Second, you need to decide the thread, how much the threads in your particular application have. Second and third is like you can run all the logical process of the particular one. So it's all about first library, second thread. So you need to decide this both thing. Okay, so because of that, like for better management and flexibility of the code, you can actually use this particular library and thread system. So as for better management of the particular one. So that's all about I am talking here. Like pseudocode help you to understand much better. So that's how I try to explain. So you will need to decide first library, what kind of library to use to better management of the thread, how the each threads of work, how can they actually share their particular information and such a make the communication between both of them, and how the process communicate each other, operating system and like your software. So we need to decide that particular stuff. So we need a process and thread according to it. So that's all about for process and thread. And again, if this one going to productive for you, if you learn something from there, then it's my pleasure. See you soon.